Okay, so we are officially recording. It's November the 13th. So like I said, it's my twins' birthday, so it's so exciting for them. They're still at the age where they love birthdays. Oh, it's so fun. Um, but let me talk about the schedule because we've got 2 more weeks together and then we're gonna have the final exam. And so we're gonna have a big break. There's no more homework assignments, so it's kind of, well, I think we got one more reading, one more Esri exercise. That's about it. You can see your running grades. To be honest with you, the grades just kind of fall where they do. If everyone gets an A, everyone gets an A. I'm not going to lose my job if everyone gets an A. Because at the end of the day, your boss and future employers aren't going to care if you got straight A's or you just got through, and to be honest with you, in your master's and your PhD programs, the school stuff's easy. It's all the other stuff that you got to deal with, life and kids and other jobs and money and all the other things that life presents. And most people in their master's and PhD, they don't drop out because of, I can't finish this class. It's all the other things that life presents. And if you can, handle all those. And your employers aren't going to say, oh, no, hey, they saw, hey, you got a C in geostats, and all right, maybe you're not going to be a geostatistician, but how many geostatistician jobs are really out there? Okay, you graduated, you got your piece of paper, move on. No one cares about my grades from 30 years ago, to be honest with you. And even what I got in my PhD program, no one cares. They just got your PhD, got a couple papers, and all those other things. So those big things are what we're working for. More importantly, that position paper is what I want us to focus on. So what we got, our schedule right now is today we're going to talk about spatially weighted integration. I'll do a little bit of a demo. I'm not the best with spatially weighted regression. We'll start talking about circumventing issues in geostatistics. This is kind of one of my favorites because whenever you write a paper, what do you always put at the end? Conclusions, but what else? References before that. Discussion. What's discussion? What's the, what do you, and when you write a paper, what's the discussion? Results, all the things that maybe could have changed the results. And so we're going to address some of those things with sample sizes. Some of the things we were just looking at with your data. Hey, we had some incomplete data. Some people typed in, this address, it was wrong. And, our years and all those other things. Hey, we're using a different system for these years. I can't discern the years for these particular things. And so we've got a lot of disharmony with some of the data. So talking about addressing some of those challenges, one of those things will be logical consistency. Because one of the things we saw, there was nothing in Durham County in the northern part. Well, that was a naming convention. So we got to go through and match up all of our naming conventions and all those other things to get that data nicely and neatly. And we'll talk about some of those. We'll start talking about those today. Next week, we'll finish up with circumventing issues in geostatistics. And then we'll prepare for the final. So I want to really take a good hour to prepare for the final. Undergrad students, once you take the final, you are all done. And then the 27th, we will not meet because it's the day before Thanksgiving and I'll be on the road to Indiana. And then the week after, the 3rd, that's a Tuesday at noon, all assignments will be due. And then on the 4th, which is, I guess, 3 weeks from today, we'll be meeting here at 5 o'clock for the final exam. You can take it wherever, to be honest with you, for online students, it'll be given Tuesday through Thursday, just because they're online students and I can't force online students to be at a particular place at a particular time. But face-to-face students, it'll be given at this time, so I'll provide a password and you could probably figure out what the password will be from, from the announcement, but that's more than fine with me. But the final exam will be open, taken. It'll work the same way. Well, it'll be some Excel. It'll be some other things. I think a little ArcGIS Pro. I think it'll be open book and timed at 2.5 hours, which is a class length. Because that Friday, I don't care if you're graduating, not graduating, whatever, all grades get submitted to the registrar. Because I don't like doing the the graduating seniors, I just get everything done. And so it's kind of fair for everyone, and people don't say, well, I'm not graduating, so I don't have to submit stuff until the 9th. And I'm like, the 9th, I'm going to be in DC, the 8th, 9th, 10th, 11th, 12th, I'm going to DC for AGU, American Geophysical Union. So I'm not going to be up in DC and grading your stuff, so it's just, that's the way things are. So this is what we got scheduled right now. A couple things while I'm thinking about it is that we got, it's the season for internships. So we got internship season is kind of started. There's a number of good internship programs out there. We have a great program called LitGeo, Literacy in the Geosciences, which helps facilitate geosciences, especially for minority students. So we're working with the University of Puerto Rico, Arecibo, and so some of the cultural language barriers that some students face, and also women in the geosciences, which we're really trying to push. But they started talking about internships, and this is a good internship program here. This is one that I like. It's open a little bit early, but you can see November 4th it's open, January 6th it closes. So you got about 2 months to apply for internships. We've had a couple of students do these before. They pay $15 an hour. All right, you could probably work at Walmart over the summer for $15 an hour, but guess what? You're going to get experience doing this. You're going to get experience doing this. These used to be really a lot cheap, a lot cheaper. They didn't pay as well a couple of years ago. And we got another one coming out called the HBCU NCDOT internship. And so that's a little bit more on the technical side, but they have photogrammetry, they got some GIS. But if you were to click on, I'm just going to click on apply now. But if I click on apply now right here, you can see some of the internships: education internship, history intern, husbandry, archaeological conservation. But I'm going to type in the word GIS. And you can see some of the applications of GIS. Water quality grants, GIS support. This is hybrid. So we got some chemistry people here. So you like chemistry, and I don't know exactly what this does, but this is GIS support. Create an Esri story map. Has anyone heard the term Esri story map? Okay, Esri story map is basically a big web page that you can create that you insert your web maps into. Because when I'm working with these things here, I've got these maps right here. I'm working on a geocoding example right here. I can click the button share, and I can publish this directly to the internet. Publish this directly to the internet, and I can make something called a web map. Okay, and then a web app. A web app is basically a page that contains your map so people can't fiddle with it. If I have a web map, I can add content to it. I can change colors, and hopefully the people don't let you save it or whatever. But there's a lot of other things that we can do here. This particular class here is kind of focused on the geostatistical geoprocessing side of things here. The other thing is, if you don't know what a story map, what can you do? Google it. Go to the Esri training site and type in story maps. Story maps are probably the most intuitive things out there. You add text, you add a little map that's sitting in ArcGIS Online, sitting in our content, and you click publish, and you've got like a nice little story map. And you can make these increasingly complex. So some of our students were very qualitative or very artistic and do some really neat things, not a lot neater things than what I can do. I thought this was neat. GIS support, field biologist, and GIS mapping intern. So you can click on these things here. This is in Wake County. Youth Advocacy and Involvement Office here, using GIS maps to review satellite imagery of lands donated for conservation to identify areas that require on-site surveys to ensure that protected areas are not compromised. Like this is, to me, this stuff's pretty cool. And some of the things about internships are that you can kind of figure out what you want to do, but you also figure out what you don't want to do, and you're not really committed to, whole career, like, I don't want to do this. I don't want to do this stuff. I don't want to go outside. I kind of like going outside, but it's a whole effort to go outside. And I know when I go away for the day, I'm gonna have, 60 emails of stuff that people need from me, and so I always I get a little bit frustrated by that. That's probably more me thing than anyone else, but earth science, environmental science, planning, conservation biology, entomology, parks and rec management. This is really neat. We had a student who did this internship with Parks and Rec, and he kind of moved on, and I think he's looking at jobs at the USDA and some other things like that. But, it goes from May the 19th. We teach a field mapping class during intersession, which goes from May the 5th to May the 16th, where we're going to do story maps. We're going to do a field day. We're going to do, drones and all those things where you go out and basically collect data in the field, collect. And Michael, I'm going to pick on Michael here, but the exercise that we did with nearest neighbor analysis, he used his little phone to go out and collect the actual locations of all the emergency call centers during that class. And so what are things that you want to collect? What are applications? All right, telephone poles. What are the telephone poles that you want to collect? What's the condition? What's information about those that you want to collect? And we also connect it to using Bluetooth, using a high precision GPS. And so I got a couple of neat maps that I create. If I think of them, I'll show them after the break, where I collect it using my phone, and then I collect it using the GPS. And that GPS, the phone might be 15 feet. The GPS is, pretty good. And that's not even like high grade GPS, because there's going to be situations where you want to collect high grade GPS as opposed to your little phone here. If I'm zoomed out at the county level, it's not really going to matter. But I'm looking at like campus level stuff. Campus level emergency call centers, I'm going to want to look at good stuff. And so that class meets. In the past, I had money to pay student fees. And so I pay, we basically bribe everyone, because I get paid to teach over the summer, a 2-week class, but we pay for the fees for all students. And so we reimburse fees on those to get students to know what class. Of course they do. It's the ASC 50/50. Yeah, 50/50. It's called field mapping, and it's intersession. And basically in that class, we meet for a week. It's an intro to GIS, and then we kind of cover the different applications. We got something called Survey 1, 2, 3, quick capture, and we go out and do drones for a day. But the last day, what I'm hoping to do is we're going to go to a local park, and then we got something called ground penetrating radar, which I'm hoping to use. I just went through the purchasing system today, an infrared drone. What's so special about infrared? What's infrared mean? I used to hear that stuff like on the Incredible Hulk. I remember the alpha waves and the gamma waves back in the day. What's so special about infrared? Exactly. Detection, healthy vegetation. Two things might look green, but more healthy vegetation is gonna ping or return higher values on infrared. And then also thermal. Thermal, what is thermal? Heat. And thermal is an emitted wavelength as opposed to a reflected wavelength. So if I were to turn everything off here, you wouldn't see what color I am, but you could still see the heat or detect the heat coming off of me. And it's kind of funny because, I should bring it in after the break, but you can kind of get the little thermal thing, and you can see nothing coming, lots of heat coming off my head, nothing coming off my eyes, because the glasses are kind of blocking it, where most other people have hair and hats and all those other things. But I don't want to kind of go too far off here. But this is really neat applications here. Apply for these. The worst thing they can say is no here. But water quality, so our chemistry folks, our biology folks, our environmental science folks here. Digital research and exhibits here. This is another neat one where this is Mosaic NC. Intern gain experience, archival research, public interest, public history. One of the things that we're working on right now with the history department is creating a historical GIS class. How are GIS and history gonna mix and meet? a ground penetrating radar where we go look for graves or unmarked graves or whatever. But back in the day, they didn't have GPS. So you see those paper maps that are hand drawn, well, we can give those GIS coordinates, using known coordinates now. Hey, there's the city of Oxford. There's the corner of, that's, the corner of Person and Durham and Orange County. I know these points, and then I can rotate the map to give it GIS coordinates, because it's just a map. You just scan it in, it's measured in inches or measured in pixels. So the whole field of historical GIS and its relationship with public history and the utilization of story maps to tell powerful histories that are going to be persistent, I think is really interesting, groundbreaking. So those are one of the things that we're looking at as well. So I think this is neat here. And then you can see, the digital research, complex challenge real estate portfolio. That looks pretty neat. Updating emergency management building footprint GIS data. EMS stuff. This is neat. ArcGIS Pro. Intern will assist the GIS section with collection, creation, deletion, quality control of geospatial, I assume this is data, using ArcGIS Pro in southwest part of NC that have 2013 aerial imagery. And so look at North Carolina environmental management to mitigate and respond to natural disasters like floods. Like this is just data development. This is what I did for the military. Tracing outlines. It's fun for like an hour, like trace the little outlines. It gets really boring for a long time, but you're getting experience and making $15 an hour, getting experience and maybe getting paid somewhere else, because I know our PhD students get paid, throughout the year. This might be something, to do, especially if you're, salaried or whatever. So I think this is, lots of opportunities there. Please look at these. Andy, can you apply for these? Michael, are these ones that you can apply for? Okay. Yeah, I'm just asking them because I want to make, I'm not sure, because they're international students, so I just want to make sure. Oh, let's see. What am I doing wrong? I'm doing something wrong. Okay. Must be NC resident. Okay, so you got to be an NC resident. So this doesn't even applicable to out-of-state students who attended college. But any NC resident, open to you all. Okay, please take advantage of these. There's another good one, NCDOT, HBCU internship that comes out later. I'm kind of good. I get along well with the folks who run that. We always try to place students there. And then if I think of it, and at the break, a couple things that we have coming up while I'm thinking of it. We have a couple of defenses coming up, and maybe in the announcements, I'll send these out. We have Benjamin, he's a master's student. Michael, he is a master's student. He's an online student. Benjamin is a face-to-face student. He's local. But we have a couple of defenses in this room next Tuesday, one at 1 o'clock, one of them at 2 o'clock. Benjamin, he works for local food pantries. So he goes, and what he wanted to do is he went to like different convenience stores, food lines, all of these on a regular basis, and collected the prices of different staples. How much is a loaf of bread? How much is a gallon of milk? How much is a pound of bananas? He wanted to keep the consistency, because a lot of times when people do field collection, and we'll talk about this with circumventing issues in GIS, people always, this time I collected this milk, and then I got the coconut milk that my wife wants, and then I got this, and it's gonna spike up and down. And he did a really good job of keeping consistency with it. And he went and created something called Survey 123, a survey. And so he was there, clicked on the little story, he typed in a little price. Just think about, what information do you want? So he just went, typed in 62 cents a pound, $2.29 for a gallon, $5.99 for a loaf. And then he had a little store that he loaded in, and so he went and collected. So he's not sitting there writing in notebooks and writing all these things and all that. So you create a survey. What's all the information that you're going to want to collect? Just like your fire information. What are all the fields you want to collect? There's a lot of other ugliness with the 0, 1s and the 1s and everything that don't line up. So he's going to do that, and he's going to show his results. So he's going to map the areas, and basically, as you can probably guess, like convenience stores in the lower income areas have the higher price food, and so kind of placing additional or more burdens on marginalized communities. And he did this for South Durham, so kind of starting around here and running south to about 40 in South Point area here. So he lives local, works local. I think food pantry, food security is something that he is passionate about, much more passionate than I'm about. Next, we got Michael Berrien. He actually was a hospital administrator over in Alamance County, and then got sick of it and came to us as a transfer student from Alamance Community College. So he did his undergrad here, did his grad here, and he got accepted to a PhD program over at North Carolina A&T. So he's working on there in the College of Science and Technology. He's hooking up with someone on a NASA grant, kind of the same program that we're working with, but he's leveraging machine learning and UAVs for object detection and identification and natural hazard response. So this is like right up a lot of people's alley these days, but he went and took pictures of drones with drones and satellites to figure out if you can detect flooded areas, railroad crossings, all these other things which are important, and mostly using the machine learning algorithms that we have. And what we're going to do next semester is try to integrate some of those machine learning out for 1 week in our data science class. So I've got some good imagery of the parking lot. Hey, can you go and pick out a car? Because I don't want to pick out all the cars, So pick out 1 car, or 2 cars, or 3 cars, and see if you can pick out the cars versus the not cars to see how many parking spaces are open, especially in support of, transportation planning on campus. Because you come here at 12 o'clock, I'm not getting a parking spot out there. I'm like hustling here. My wife asked me to drop off the kids yesterday, and I'm like, I might get there after 9:30, because I got to go over to Kernersville, turn around and drive back. It's like, I got to go half hour in the other direction, turn around and drive all the way back. So it's like a 2-hour commute. So like, I'm going to get there like 9:30, 9:45. I might not find a spot. I might have to walk. But I think we're going to integrate those. So these are them next Tuesday. If I think of it, I'll send an announcement to these. And then the other thing next week we have going on is this GIS Day. Or grad students ask for extra credit? I would just like you to go to benefit yourself, I'll think about it. I don't think most folks here need extra credit, but all right. And then next Thursday, actually Wednesday is GIS Day, World GIS Day, but I kind of moved it to Thursday just because of room availability. I do have a WebEx, but I want all of our students, the ones under me, that work up local students to kind of attend in person. But our focus is going to be on majors in the workforce. These are all former students who like literally sat right here, who are all like working locally. And no one cares about their grades. Some of them were really like straight A students, some of them A, B, C students, and they had the soft skills to kind of pick up and do great things in the workforce. So we got Rebecca. She's a really good cartographer. Her maps are amazing with the colors and contrast and everything. Nelson, great success story. He came here and he's just done great things. He wanted to go to conferences, wanted to go to workshops to improve his personal presentations, speaking and writing skills. And he's some GIS manager over at the NCDOT, and he works with Roderick. So these two work together. And then Mike was here. He was a non-traditional student. He's probably in his mid-30s. He was a history and education major over at Guilford College and kind of worked in music for a while and said, I want to go back. and he did web experiences, redlining projects in Asheville, amazing things with historic data. And now he works for the NCDQ Division of Mitigation Services as a watershed planner. Watershed plans using GIS. And then Corey, he made that map right there. He came down, he transferred from Alamance Community College, and then he did some work up in Pennsylvania, went to a college up in Pennsylvania, played football, and that didn't work out. And he works as a business systems analyst in the Department of Public Works, mainly I think with sewers and underground water lines for City of Durham. And they all sat here and now they're out doing great things in the workforce. And so I'm hoping that one of you will be this person. One of you will be this person, but I'm going to have a short intro. We're going to have some short talks by BBGS students. And so I might recruit Andy or Michael or whatever, just 5-minute quick talks about, hey, this is what I'm doing in GIS. This is my current research. And then they're going to talk for about an hour. I always like to focus on the soft skills because anyone can kind of point and click, but how do you kind of go from a watershed manager to he's like a GIS man. This guy's in charge of people. He's got people who works under him. And when I speak to the people at NCDOT in photogrammetry unit, they just they love Nelson. Love him, man, and I especially love where he came from because I never had to worry about internships with him because he always went out and got his own. He got one of these NCDOT HBCU internships and I liked him so much, they just kept him. It's just like, keep working throughout the year. I didn't have to worry about his funding or anything like that. I'm always scrambling to get funding for people and I never worried about him. He got his own, figured it out, never asked for, anything. And so great bunch of students here. Hopefully you can be here, but I've been talking for a while here. I get a little inspired hearing about some of our students, some of the things our students are doing. But today I'm going to talk briefly about spatially weighted regression. I'll do a quick demo. We'll have a break, and then I'll start talking about circumventing issues in geostatistics. I think it's the last of the Esri exercises, and then we'll kind of call it the day. So there won't be any hands-on component today, except for my little demo here. So I'll talk a little about spatially weighted regression. I'm not the biggest fan of it, just because I don't know as much about it as I should or as I'd like, because we create this y equals mx plus b. And the one thing about spatially weighted regression is we create individual y equals mx plus b. Now, when I talk about this y equals mx plus b, what am I talking about? What is this y equals? It's just an equation for a line, a regression line, essentially. But it could be like multiple variables or whatever. And so we create one of these for each of the unit where that location is going to be also part of the equation, because previously we just had y equals mx plus b. We had an independent variable and then one dependent variable and multiple independent variables. So what are all the factors that explain by mail voting or cancer rates or whatever, or try to explain these? And so this takes it a step further by looking at the idea of spatial dependence, the existence of functional relationships between what happens in point and place versus what happens elsewhere. And so essentially, one of the independent variables to explain the dependent variable is location. And we look at the idea of spatial heterogeneity exists when the mean or the variance and the covariance drifts over mapped processes, basically place and space location. And so typically this spatial heterogeneity is typified by regional differentiation. And so we have these spatial communities of social processes which have taken together, help bind social space, all this stuff here. So this one confounding variable that we have here, and this is kind of the beginning of geographically weighted regression, is only about 30 years old. I've got some neat articles in chapter 13 that talk about like the beginnings of quantitative geography. Because when I took geography in like 1990, 1991, I didn't do any of this stuff. I was doing like What's the capital of India? What's the capital, all these countries, Zaire. Zaire is not even a country anymore. You know what I mean? All these stands, I got to learn all these stands now. Kyrgyzstan, Turkestan, all these other things here that didn't exist, in 1990. They existed in 1991, Christmas Day, 1991 was when some of those things came about. I had Yugoslavia growing up, but no more of that. And so, but that was my geography. Now that it's just really small part of geography. And in the 50s, 60s, and 70s, there was what we call the quantitative revolution, but it really wasn't until we had good desktop GIS solutions that quantitative revolution and the quantitative powers were able to come to users like you and me, instead of just kind of the special few people that knew how to program. So we have this idea of geographically weighted regression where we have this y equals mx plus b, but we also have this location component here. And so when we look at the result of spatially weighted regression, we're going to basically say everything's got a y equals mx plus b attached to it. And so we have a place, we have labor structure, political climate, population composition, population health, and then these are the other sets of independent variables that contribute to it. And that's it. And that's pretty much it here. And so we have these big, ugly we have these big, ugly equations that we looked at before, especially when we get more and more variables. And then we add this at the end, which is the spatially weighted contextual characteristics that basically utilize location or throw the location into it. Now, when we run it, and I ran it already, so I just kind of wanted to see what it looked like and how we explain it. Basically, what we're going to be looking at are the outliers in the z-scores of these brand new and independent y equals mx plus b's here. So there's a lot of local methods for spatial data analysis. And so we have this univariate analysis. We have some of this multivariate analysis here. There's a lot of different ways that we can kind of look at this with the clustering, but this is our spatially weighted regression right here, or geographically weighted regression is another thing here. And so the idea of local indicators can also be applied to indicators, to regression. And so it's called geographically weighted regression because it accounts for location, which is going to be unique for each of these local variables. Now, what's local mean? When I talk about a local variable as opposed to a global variable, what's the difference between the two? What's local? What's that?
The scope.
The scope, exactly. Global describes the entire data set. A local is going to describe each single one. And so things like R squared will describe the entire model or the entire data set, the mean, the median, mode, the range, standard deviation. While we have z-scores or these probabilities or these GI scores from our clustering statistics that do that. So we have spatial weight metrics, which apply to the standard formula. And so basically, GWR is exploring and identifying variation in statistical relationships over space. Okay, well, what's the big deal? That, to me, I'm sometimes stuck in the so what, why is this so important sort of thing. And that's why I kind of want to combine this with other things and kind of talk about some of the internships, some of the soft skills, some of the other things that we have coming up. So it's a way of explaining spatial heterogeneity or spatial non-stationarity, where the same stimuli provoke a different response in different parts of the region. And we kind of probably just saw this with the elections, where that one group of people are going to react differently to something than another, but this is going to change over place and space. And so we can look at our study region. We have grid location, we have moving windows, right? This whole thing called the buffer here. And so each of these is going to have different R squareds. Now, what's R squared mean? This is the plot of R squareds from a GWR model. What do high R squareds mean? Think about the last couple of weeks that we talked about. Something has a high R squared. What does it mean? Closest to, I hear good, closest to what? Let the mean be expected, exactly. It's close to the expected. Okay, so basically, with these red ones where there's higher R squares, it can be explained by the models better than these other things right here. These other things have a lot more unknowns that we have there. Because when we run these R squareds, like what kind of, good R squareds, especially in like sociological, geographic research, we're going to be looking at like 0.4, 0.5, 0.6. There's still a whole nother 40, 50, 60% of factors that you can't explain. Not random error, but just things that can't be necessarily quantified. And so these areas in red fit our model better than these areas that are lighter. Okay, good, bad, or indifferent. Now, what are some of the issues? And we'll talk about those next, because if I just throw like 50 different variables into a model, well, some of these things are going to cancel each other out. Some of these things are going to be related to each other. So we need to be intentional about the variables that we utilize for them. Okay, that's really important. So when we look at this GWR tool right here, we need the kernel type and the bandwidth and the distance, and we run all these. And to me, it's really important that we understand, what we're running right here. And that, to me, with the GWR, I don't want to say I don't understand, but I don't necessarily like what we do here, because we're going to have a different model for each enumeration units. It's truly local. So we might get some R squared like 0.54, 0.4, so we have all these other factors that are going to be explained otherwise. And we're going to look at the results right here. So you can see the results, standard deviations, the regression coefficients of them. But I'm going to show you an example right here that I ran, and then we'll take a break here. We'll take an early break, and then we'll kind of work on look at these things here. But what I did here was ran geographically weighted regression. It is sitting in the modeling spatial relationships tool. So it works the same exact way here. But what I wanted to do was map the age-graded death rate. So this was the age-graded cancer mortality rates across the entire state. And so you can see that this is just mapping the median age of females in North Carolina here, which I thought was just kind of interesting right here. And I wanted to explain it using a few different factors. One of them was the median age. One of them was percent minority. Another one was poverty rate. And then another one was medical facilities per 1,000 people. So the number of medical facilities for every 1,000 people. So I think I just counted the distance or the number of medical facilities within a zip code and then normalized by population. And that's going to be spatial in nature. But when I run it, I get something like this. Now, in reality, what do all these white values mean? Anything in white, what's it mean? Not significant. Exactly, not significant. So it doesn't deviate from the model too much. Because what does it say over here? Standard deviation. What's the unit? What are the units of measure for standard deviation? Units of measure. Why are you shaking your head? There are. Okay, exactly. Because it's a standard deviation divided by it's minus the mean, all those units cancel out. So high standard. So basically, areas in white, they fit the model the best. Okay, so it's a little bit different than our clustering. Our clustering mean it just wasn't significant. Okay, and typically when we create these models, you want them all to be white when we have this model fitting, because the areas in purple or the areas in blue or whatever those other colors we are basically highlight our outliers. For that in cluster analysis, we want outliers. That's my whole goal is I want outliers of this. I want outliers of this so that we can maybe look at socioeconomic, demographic statistics, attach those using your two-tailed t-test or something else. But here with the model fitting, now we have 770 zip codes right here. It's going to be difficult for it all to be white. Now in cluster analysis, if every single block group or everything single zip code were yellow, what does that mean? If there were no hot spots or cold spots? What's it mean? Could mean a couple different things. Another variable?
Yeah, that's minimizing the separatist information. Like it should be some information that shows how it responds. But if you have too much data, it can swing.
On the right track, yeah. What about there's no clustering? Now, what does no clustering mean? They're all the same, or you got that checkerboard pattern right there? You know, that checkerboard pattern where there's no highs around highs and lows around lows. And so that's what we have there. So we can look further at, look a little bit further at the data here. And so what we have here is this. To me, the thing that I don't like to do is I right mouse click, I open attribute table, and now I've got 710 zip codes. Because if you look at this thing right here, this says zip code data pop 500 GWR. That pop 500 was that we extracted out only the zip codes that have a population of 500 because I wanted to get rid of your kind of small number issues right here where I have a zip code with 4 people and 2 of them happen to die of cancer, and that makes the cancer rate go up to 50% because the cancer rate is going to be like less than 1% over this period of time. So what is that 50 going to do? It's going to pop that mean up. And then what's that going to do to your hot spots and your cold spots? It's going to skew them. And so we got rid of those, those outliers. And also 0 values. If there's 2 people there and it's got no cancer deaths, well, that's going to be a 0. In reality, you probably aren't going to have a lot of 0 cancer deaths with population of 500.
Was 500 just a?
Just something I picked out. That's what I picked up. Because if I got to 1,000, this number was going to be smaller and smaller. And then I was also getting a little bit scared because we start getting rid of county, we start getting rid of zip codes, and then those spatial relationships are going to be compromised. So, hey, you're not my neighbor. No, you're not, because I'm not part of the data set anymore because I'm not part of the 710 because I don't have the high population. And so in reality, some of these low populated counties, I don't have any neighbors. I only have like 2 of them are my neighbors because these other ones really don't exist. Now that's a really good question. Yeah. And so when we look at this here, what do we have? We have an intercept. That's our y-intercept, right? Y equals mx plus b. And then I got my standard error, my pseudo t, my significance, all these other things here. But this is our y equals mx plus b. So each of these is going to have its own independent y equals mx plus b. It's going to be a little bit more complex than that because, well, for a lot of reasons, but because we've got multiple variables. So combinations of the poverty percent minority, the healthcare access, and median age, or whatever I threw in there. And so you can see the coefficients for median age, which are different. The coefficients for percent minority, which are in as a percentage, the coefficients for poverty rate, which is negative, and then I move all the way over coefficient, and then each going to be the difference between the predicted and the expected. So using that individual y equals mx plus b, just for this particular zip code, it says it's going to be 4.186772. Somewhere over there, it's different, and it just subtracts the 2. This is that standard residual, which I assume is just going to be normalized, because at the end of the day, what do I care about? I like local R squareds and things like that. So our local R squareds are going to range from what? 0.04 to about 0.08, a little under 0.08, meaning that only 8% of age-graded cancer mortality rates can be explained by what? Percent minority, healthcare access, poverty rates, and median age. That kind of makes sense, right? What are all the other things out there that can explain cancer mortality? What are all the unquantifiable things that can explain cancer mortality that we can't even put into tables like eating habits, your individualized eating habits, genetic predisposition, family history, all those other things, access, carcinogens and bad water and all those other things. So these are just the things that we can quantify. And so that's what this R squared really means here. And that's why these things are relatively low. So this is a good example of GWR where it creates its own kind of unique y equals mx plus squared for each of these here. And that's about it for me here with the analysis. Under tools, you'll see that it's under modeling spatial relationships in the same place as OLS, and then generalized linear regression as well. So let's take a 10-minute break here. Let's take 10 minutes. We'll come back at 6. I'll start talking about some other things here. I'll start talking about a couple of other things here. I'll bust out the thermal if it's working for me, and should be good to go here.
Yeah, it's just straight up back. Straight for you. Yeah, you're running straight.
See, 3:30, it wasn't telling me anything she could say. I promise you, and I think the best person was back, so it was great. Maybe.
Line. Are you going to be informed searches? Okay, I mean, there's different aspects to it. Like there's some where you're being represented, you live in different countries, different specialty. It depends on what you want to represent. There's many aspects to it, but they're having a career that you see things.
Yeah.
The Tuesday, but it starts at 10, so I'm gonna have 10 to 12, then I'll come here. No, so it's gonna get. But I would just like for it, it's gonna be at the Rose Conference Room. And so, I just think it's important, whatever we're representing, we're actually building these relationships. Travel?
Yeah.
Well, you do, yeah, you do travel. See, like, first of all, I try to those films, like, just a picture come across the people. No, make sure the meat is cooked well, even if we like slightly raw meat, just make sure it's cooked well. Yeah, white or brown, things that are like the packaging is still properly, like expiration dates, like check that stuff. You should be cool. Eat fresh, like just eat fresh, just do it fresh.
Either some civil life. Down, speed.
Yeah.
So many fresh teeth.
Oh, yeah.
Or
Come on.
Yeah.
Oh, yeah. Yeah.
And do a juice versus water. That's the reason why, I don't know the exact time. Well, that's why wine became so popular. Because the fermentation process versus drinking water.
Safer. Yeah.
It is. One.
No, man, I'm happy. Silly. And even alcohol, you can whatever.
I need to give some, yeah. Yeah, this is facts. Not last to me. Yeah. The family. Oh, that's what I said.
Oh, that's my.
You go, man, you stay here. Yeah, I was already here.
I really feel like we're gonna need to start planning it with meshing with other countries. Right now, like US is lower, it almost doesn't have much longer. And as far as like, because we were big on like agriculture and like we were kind of like one of the food and stuff, but we're losing like farms due to drought. So like our money maker is Venus, we're gonna really have to seal the deal with other countries and hopefully countries closer to us, like going across the water into the country. So I'm like,
Yeah.
like all communists.
Yeah.
Avocado, we can't slow down. Say it again. What? What? It's the bigger one.
Yeah. The real one with the big.
Scientists, they find something. Even though in Arizona, back I got 20 wildfire. It's one of the first that vegetables they kind of. It's just thinking food, but. Yes, and then it's like. The best citrus I've had was in the Mix. The locals will bring me like fruits and vegetables, the best in the Mix. I'm thinking like, it's so dry out here. Water is a, that's pretty good too. But, yeah. Right, like the sour, I just saw that from Canadian grocery store yesterday. I know, and I'm getting citrus all of their trade. But I gotta stay talking to y'all. They are in and out of the medicine. I'm trying to keep my life. I know you genetically modified, but you need juice. Yeah, that doesn't mean about like. Oh, I just want to eat the whole skin. My skin to me. I used to eat the whole skin, especially when I was out in the field and stuff in the service. Like they were always like, okay, make sure you clean the basket so don't leave the waste. I was like, I'm just eating the whole thing. Charming. Bro. It's something. It's something.
Well, you know,
See?
not it. Okay, very.
It's he being like a brain or something. Like, switch to like.
Oh, right.
Right.
They still get it. So you serious? The Coast Guard is more cooler than any of the fields, in my opinion. Like, I feel like they're going, they got little boats, big boats going off in appleways and highways and waterways. Y'all do. You know, I'm in high school.
More chemistry. Yeah, close.
Because I'm getting to school. Wait, I'm So is it within one of the branches or is it a separate board? Also, then, okay, that makes sense. Cause I'm like, I'm brain goes, but under, yeah, there's different, like.
It's not like, you know, Jenny would have like, it's not, it's separate branch. But they don't have.
It's going to start.
They don't have.
So it's.
Most people have it, that's what I'm trying to tell them. It's a good word.
Tell me. Yeah.
Yeah, there's a med school up at Walter Reed. Yes, military has it. My kid was stationed up there. He's a foreman. Yeah. And he's embedded now with the Marines. He's gonna go back to Annapolis. So he did some health school down at, what's the one in San Antonio? He did that, but they have a med school there, and I'm sure you gotta pay back, you go to med school there, but you gotta.
So is it considered under permanent?
Sure, yeah. We got a whole med school at Walter Reed. Just like, once you had the med school or two, they got one. All right, I'm almost set here. All right, couple things that I found. I found a little thermal detector here, which I think is pretty neat. It's always kind of given me issues, but this detects thermal wavelengths. Oh, this is pretty. It's like a little sun. I'll take it.
See the lights too.
They take pictures. It's thermal, so I'll watch this.
Yeah, we turn the light off.
Doesn't look any good.
Chinese medicine, the fire.
There's gonna wear his hat, and he with the glasses. Good stove. Yes.
Okay. Was a, electromagnetic something at the NASA Center? Okay, at the NASA Center, and at that time. Okay. Was that a purple rain? It's like resting your body. It's like. So Eric, admitting heating percentages.
All right, yeah, so this thing's a little, this thing cost me like $179 at the time. Because this is thermal. The thing about thermal is that it's emitted. You know, basically, and so when you look at physics and black body radiation, you need a lot more, I don't know, area or whatever. So when you look at thermal imagers, they cost a lot. And especially with remote sensing, like the remote sensing, we're not going to be able to get like 1 meter or even probably even 10-meter resolution thermal with high accuracy because there's not enough energy being emitted from the earth for you to detect it. So usually what's the best thermal imagery that we have out there? All right, 30 meters, 90 meters, yeah. 90 meter. I don't do too much with it, but what we're doing with our drone, what we're gonna buy next is a thermal drone. So I'm not sure what the resolution on that's gonna be because, you know, when I'm, 150 feet up with my current drone, I'm getting like 1 centimeter resolution, like literally 1 centimeter. I got 20 meg images. It's pretty good, really, really good. I don't like flying super low because you get the angles which get really weird really quickly. All your sines, cosines, and tangents and everything, all that other garbage that we deal with that you don't want, you need to correct for. So I like this. It'll be interesting with the infrared and the thermal. Now, why do we care about thermal? Like, what would be some applications of thermal? Like I went and took a picture of a lake. Why do I care about the temperature?
Temperature of water to see if it's actually in the pool versus.
Exactly. Heat pollution. That's another type of pollution out there. Heat pollution. And, we now know that especially localized organisms have very minute, they only live in certain environments. You get a couple degrees higher, a couple degrees low, especially high in this day and age, they're done. You're going to kill those. And those are things that our eyes can't see. Same thing with the infrared, because that electromagnetic spectrum, there's a whole lot of wavelengths there. I think thermal is really on the far end of those. But the visible light, the blues and the red, this is just a tiny portion of everything that is out there. And I think it's kind of neat, you're looking at stuff that your eyes can't even see or can't even fathom. Other things we're going to talk about today, and then I'll start talking about this, is when I look at my modules, and we're going to kind of talk week 13 right now. And so we talked about geographically weighted regression. There's an Esri tutorial with it. It'll be due next week, and I don't think there's anything else here. So I want you to take a course related to hotspots and geostatistics of interest to you, that anything, hotspots, clustering, anything, put it in there, take it for your own edification. Okay, maybe type in the word regression, linear regression. What directions do you want to go there? So I posted some readings up there. These were some of them that I found here. So this is a paper that Dr. McGinn and I wrote. This is a statistical and geostatistical survey of the relationship between COVID-19 by mail rates. I've talked about this before. The one thing I have right here is, right here, I've got a thesis that I'm working with. We want to look at the relationship between by mail voting and COVID-19 pandemic. So with your position paper, I want to start to kind of really hone in on a research question. Relationship between COVID-19 and by-mail voting rates. And I even went a step further and said, I'm going to assume or hope or whatever the right word is, that working thesis is that regions with higher COVID-19 rates would have higher by-mail voting rates. Now, I don't say this, I know we've looked at this paper already, but a lot of this was data development because we have big voter registration records. And here are voter records of basically how people voted, not what they voted for, who they voted for, but how they voted by mail, absentee. I think these days probably what day they voted. And you can see there's spatial relationships between the mode in which people vote, which I think is really interesting. These data are just starting to come out now. But the thing that I have down here is conclusions and discussions. You know, this is what we're talking about. And was a real short paper. The limit on this was 3,000 words. Meaning like that's the most you could put there. So you have to be really intentional with your writing on this. And so you can see right here, I kind of talk about my conclusions and discussion. I put them all in one here, but I had an adjusted R squared of about 0.53. That's not too bad. Where the quantitative data explained more than half of the by mail voting rates. And I used about 8 or 10 different variables here. I think these were the variables right here, which were population density, median household income, poverty rate, percent minority, COVID rates. The COVID rate explain that, and I don't think they do. I think it's the exact opposite. No, not at all. Average vehicle, previous year's COVID rate, previous year's by mail voting rates. So you can see right here, which of the factors explained it. This is just using OLS that we talked about a couple of weeks ago. That's all it is. Things with the little a were the ones that were significant, but this model was 0.53. Other things that I have here. This is a paper we did a couple years ago, exploring rural food security, debunking an urban myth. So you can see grocers, results. Right here, I've got my good old, I got some pretty maps here, discussion. This is my discussion here. What are all the things that could have been done wrong here? Here, I explain here, we use Euclidean distance. What's Euclidean distance mean? Straight line, because that's what the USDA uses. Is that really practical? No. But I'm not going to go through and redo, do all those drive time calculations. You can imagine how long it takes to do drive time calculations. So we ran that here. It just says, hey, GIS, we could have done this better. So these are all the things that we need to think about with this. Also, another thing, we were talking about rural food security. And a lot of times, what is the definition of rural? Far from major cities. And we have another paper that Chima's on. Chima kind of stepped in before. Tony and a couple of us are on that talk about the different definitions of rural. So make sure you say the definition of rural. So this kind of talks about some of the challenges of just using the term rural. There's 9 different, definitions of quantitative definitions of word rural. And then the last thing here, this was a paper that we did on modeling drive times here, because this is actually up where I live near Northern Guilford High School. This is our little farm that we bought here. And then this is over here is Northern Guilford High School here. But this is measuring the drive time and distance to the nearest supermarket, which is right there in red. Now, I don't want to do this 177,000 times for an entire county. That would probably crash your computer. It might even crash my new supercomputer that I got there over in my office there. So what are ways that we can model population, so I don't have to run all these drive time calculations, because, think about how long it takes you to do this when you type in an address. It takes a couple of seconds there. Imagine doing that 177,000 times. This thing doesn't like it. This computer doesn't like it. And so these are all the parcels or addresses located right there. And obviously the smaller dots are closer, bigger dots further away. These are all drive times. So even something like this, which is really close, hey, you have to go out here, over here, and around. Where that's our house right there. I can just hop on the road and drive, even though Euclidean distance, they're different. So it takes into account those drive time calculations. But lo and behold, I still don't want to run all those calculations, even though they're more practical. So how can I model these to make these orders of magnitude smaller? And so what we did was we kind of modeled them. I ran it for all residential parcels right there. It took a long time. I had to kind of piecemeal it here. Actually, just had a student do it. And then I created like a fishnet. Let me just get every mile and sample these points. This rings a bell, right? This is called stratified random. Okay, that's something different. That's a different modeling technique here. But eventually what I did is I grouped them at the population weighted block group. So there's only 292 block groups. I population weighted it where I found the center of population, did the drive time, and it compared similarly to all 177,000 of these. And so next time we do drive time analysis for emergency shelters or fire locations, we're not going to do it for all addresses. This Mulrooney guy said, hey, if you use population weighted centroids, you only have to do it for the population weighted centroid location, because that shows where most people are at the block group level. But I ran all these cool sampling techniques. I got into some different testing, but you see this stuff here? Does this stuff ring a bell? That's your null hypothesis right there. That's your alternative hypothesis. So these are things here that you're looking at in the different papers. I always make my nice pretty maps here. This is the drive time in minutes to the nearest food source at the block group level, using a fishnet technique or whatever, so you can kind of look at the differences between those. But and I compare them all. But down towards the bottom, once again, I've got a nice little discussion here. What are all the things that you could have done, that should have done, didn't do, might have thought about later? Someone's gonna, review it and say, why didn't you do this? Okay, this is why I didn't do this. Or, go back and add these. And so what we're going to talk about today are some of the issues that we deal with, or circumventing issues in geostatistics. And I always like talking about these. And I'll probably just talk till about 6:40, and then we'll be done, to be honest with you. I'm done here. So one of the things about this is that when we look at GIS, we've got processing operating in space. Now, the other thing is we haven't even talked about time. Like, that's a whole nother thing, a whole nother thing that we deal with, that I don't want to deal with. Time's another thing here. ArcGIS Pro is really good at mapping in time. Chima, he's really good at mapping time, preparing data in time, because we also want to map as well. Where business. Okay, this class is where something is. What are relationships, spatial relationships between features? The why, we'll let you all kind of figure out that, because some of these, especially with things like sociological, you got to go out and do surveys, where that in the chemistry and biology field, you can kind of address these in the lab. So spatial analysis is aimed, and what we've been doing in this class, identify describing patterns. We've got global patterns that describe entire data sets, whether it's nearest neighbor analysis or local metrics, such as hotspots, hotspot, cold spot that just says this zip code is in a hotspot. It's a high surrounded by a high. And then try to identify and understand the processes. To me, kind of explaining these is also important because like the maps are good. Like this look neat, but which one's clustered? I don't know. You know, because these days and in this day and age, just looking, making the pretty maps is not enough. We've got these statistical tools, and that's what the geographic revolution really did, or we call it the quantitative revolution really did in the 50s and 60s, where we started to attach numbers and latitude and longitudes to these things to assess and evaluate them, assess and evaluate them spatially. And then when GIS kind of came in the 90s, it let us do this, at most of our fingertips. Because we just don't want to look and guess. So we rigorously test these. Oops. All right, started recording it. I hit the wrong button here. Okay, so our idea, we don't just look and guess to figure out which one is clustered. Because why is this important? Is this clustered? Looks that way. But we don't look and guess, okay? Lots of people out there love to look at pretty maps. To me, okay, it looks kind of clustered. Yes, it is. Could be random. Okay, because we know there's a difference between random, clustered, and dispersed on that continuum. Dispersed and clustered have some degree of intentionality where that random and literally is random. Some are close, some are far. Okay, and why do we care about this? One, that this is science. Okay, we can make pretty stuff for people to look at, but for your physician people, I really want you to take it a step further because I want to look at the crime maps and the crimes grouped by block group or police beat, or the fires group by fire. I want to look at that stuff too, but how do we really elucidate powerful patterns that facilitate data-driven decision making? Because this is how decisions are made. And, at some point in time, you're going to evolve from a, pointer and a clicker and an analyst and a specialist to a decision maker. And really understanding the science behind these, I think is important. Now, where are all the places where people can question your results? And we're going to just talk about a few of them, and then we're going to kind of end for the day here. But outliers, just wacky values. And we're going to speak specifically to that paper that we did with Alana, and that's posted there. That's the female breast cancer paper that we got published, I think, a little more than a year ago. What are the different data sources? How do we extract data? What are the scales and sizes of our enumeration units? We did this with quadrant analysis. Why do we pick the quadrant size we did? We don't want it too big because you only have like 4 quadrants there. It's kind of useful to do frequency. We do a Poisson distribution. What is that? Poisson is looking at counts. We also have binary, true or false. That's what we call logistic. And then we have Gaussian for continuous data. Population density, things like that, which aren't quite as granular. We have sample size. What are the sample sizes that we saw? We just dealt with an election where sample sizes really, they played an important part in it. Small number problem, the methods applied to data, residual mapping. This gets a little, and then use of variables that are inverse, white versus minority, but variables that are too much alike. And I posted an article here. I've got a link to it as well about some of the different terms used in geostatistics. We use the word regression, how to take advantage of those. But I'll just mention a couple of these here with the use of outliers. Gettysburg uses the word high and low when determining hotspots. What does the word high mean? Above the mean? Below the mean, a certain distance above and below the mean. And so when we look at age-graded death rates, we've got about 763 zip codes, and only we took away 38 of them, or that's right, 38 of them with populations less than 500, because when I looked at it first with the 763, my mean was 4.6. And then let me look at the other one here. And then after that, the mean was 4.3. Okay, so I went from, let me go back here. Let me make sure I go back. So when I had all 763, I had a max of 272. Death rate, 272 with a mean of 4.6. What do you think that 272 is going to do? Pop it up. Okay, pop it real far up. So what I did was I got rid of everything. So now my max, instead of being 272, is only 25.8. What's that do to the mean? It moves it down. That going from 4.6 down to 4.3 is pretty important because at first, when I did my zip codes and I did my cluster analysis, this is what my cluster was. Does anyone see a problem with this? This is my cluster map when I ran it. What's that? There's no hot spots, there's no cold spots. Why? That mean was skewed so far up that it had to be really high to be a hot spot, and the only few that had were the 272 and the 250 and the ones that basically had like one person die of 4 people, and guess what? You got a rate of 250 for every 1,000 instead of 4, 5, 6, which was the average. I take those out. What do you think this map is going to look like? I just take out the population less than 500. Same exact data. I just took out the, and I wasn't intentional about taking out the outliers, but when I looked at the outliers at 272, probably had a population of like 2 people out of 7 people died of cancer. You know, whatever that rate is, you know, 27, that's where it is, like 27.2% of the people died. So there it is. So what is high? High is, there's nothing that's going to be high unless the ones that created the outlier in the first place. I take away those 38 problematic ones, and also I remove a bunch of zeros, like 0 people out of 2 died. This is what I get. Because, you know, Elena and I were running, I'm like, this doesn't look good. You know, and we went through the trouble with age grading these things. So it should have been nice. And then we look at, okay, we got a problem. Even I would have probably liked a few more here, but does that show you patterns here? Definitely northeast of here, those Bertie County, Northampton County, out in northeastern North Carolina. What age and race of folks are we looking at? This is age graded, but these are your minority majority counties out there. These are your worst counties in North Carolina. Here, this is probably, you know, it's probably picking up some of the young people. I probably didn't age grade as well as I could have. Yeah, but these age graded death rates right here. Other errors that we have, logical consistency. If you get data from different sources, you make sure it's consistent in its structure and its coverage. The one problem, if you go to the Open Durham website and you download data for Durham Police Department versus Durham Sheriff's Office, they have entirely different attributes to store the data. Who's going to match those up? You are. You're going to have to figure it out. So I just run Durham City data, to be honest with you. And then I have to group it within all the block groups entirely within. There's still 100 of them there. Other logical consistency issues, we have our mapping age graded death versus raw mortality death rates versus the actual raw data. And so hopefully we're getting to a point in time where we want to map age graded death rates, because when you map death rates, you're just mapping where the old people live. That's it. That, you know, for lack of a better term. We've got the sheriff's data versus the Durham city data, the Durham open portal. So when we look at the sheriff's office, this is the sheriff's office data of crimes. This is this is the city data. And now we've got like different attributes for each of these here. So I got this UCR code for one of them, and I don't have the UCR code for another one. So it gets just really, really ugly really quickly. Other thing, and I'll probably just finish up here with the edge effects, and then we'll finish everything up next week. Edge effects. Edges are always kind of tricky to deal with, because a lot of times if we're just working with Swine Lagoon data in North Carolina, well, in theory, you should probably go get Swine Lagoon data all around the other states, because they're going to have an impact on water quality up there. Some cases you won't be able to get it. So when we run quadrant analysis, density analysis, quadrants, but what do we use quadrants to do? Just get a frequency count so we can look at a Poisson distribution. Poisson distribution is just a random distribution. It's not a normal distribution, Gaussian, but it's a random distribution based on a certain value or assumption where we map discrete counts, 1, 2, 3, 4, 5 quadrants. You know, I can't have 6.2 quadrants or 6.2 frequency. It's going to be, they're going to be granular, more granular numbers. So quadrants and enumeration should only occur where there's a full coverage of points here. So when I run my quadrants right here, I've got my study area right here, and I've created a buffer outside. Why did I create the buffer? So I can capture, hey, the person who lives here, they may be going to this vegetable market right here. So there's an accessibility component so that my study area really isn't an island. We use that word island sometimes. Study area really isn't an island right here, because people are free to kind of come and go from it. So when we run this analysis, so people going from this area right here might go over here to Wallace to access it. And so when I create my quadrants using my little formula right there, I can create quadrants that extend outside of the study area based on my little formula, like 2 times L divided by N, take the whole square root of that thing. Okay, and for the exercises, for the exam, you can utilize all of those as well. And so now within the study area, I can do a count and then a frequency and I can do a spatial joint, and then I just run a frequency on each of those, and I can just make my nice little graph right there to see how many have 0, 1, 2, 3, 4, 5. Another example that we have here is my study area, my deer vehicle collisions for Durham, Orange, and Alamance County here. And you notice here, I kept the deer vehicle collisions outside of the area so that I can get consistent values all the way around. You know, because if I were looking at the density right here, I might get a lower density if I'm using a 3-mile buffer, but these deer vehicle collisions are not being counted. And so sometimes we kind of run into the issue of, oh, we might have really low values right here when we do a point and polygon analysis. Well, why? Well, these are much smaller than this one here. Okay, and so make sure you have that consistency. The person who used to teach this class, he was really passionate about making sure you didn't have edge effects or anything like that. All right, I'm going to finish today if that's okay. Is that all right? Everyone looks kind of sad. But I'll finish today. We do have an Esri tutorial. Pick something that's going to be useful for you. You can just go pick something that looks shortest. That's cool, but you get the A and all that other stuff. But find something that's elucidating. You can fool Mulrooney, but you can't fool yourself. But take something that's going to be interesting. Take something that's going to be interesting. Type in the word regression. Type in the word statistics. Type in any sort of geospatial statistics, because they're really taking off with that. There's brand new tools there that I don't even mainly know how to use that get AI ML space. AIML space with the graphing and the grouping, the random forest and all those other things that I probably need to do, learn about a little bit more that didn't exist when I was in grad school. So I'll leave everyone with that. Have a great weekend and be on the lookout for any announcements. Maybe I'll see you all at GIS Day next week, or maybe some of these defenses so you can see what they look at and see some of the great work that we're doing here. And maybe so there's synergies with some of the things you're doing. All right, I'll see you all later.
Thank you.
All right, thanks.
You know.
All right, see ya.